Good morning, good afternoon, and good evening, wherever you are joining us for Operational Excellence Empowering Utilities. My name is Nicole Bamford, and I'm the moderator for today's session. On behalf of Leslie, Angeliki, Quinn, Candace, and I, we thank you for joining us for day one of the event. This presentation, Building an Industrial Process Historian with a Time Series Database on Microsoft Azure, will be given by Ergin Tuganay, Partner and Head of Industry 4.0 at Nortel. And his presentation promises to be well worth a listen. Before we get started, here are some quick administrative points. During the webinar, if you have any questions for the presenter, please submit them in the Q&A box on your screen, and these will be answered during the question session. Likewise, for any technical issues, please write them into the Q&A section, and we'll get to them right away. The widgets on your screen can be resized and dragged around for your viewing preferences. We encourage you to visit the Resource Center on your screen for additional content and resources we and our sponsors have provided for you. So make sure you're sitting comfortably, and I'll now hand it over to Ergin so we can begin.
All right. Thanks, Nicole. So, like introduced here, my name is Ergin Tuganay, and today I'm going to talk and give you some tools, practical tools, how to build an industrial process historian and solve some data-related issues and topics and challenges in your industrial environment. So really shortly, I work as a head of industry partner and head of industry at Nortel. Personally, I have a background in automation engineering and in industrial IT. I have been in this field for like more than 15 years, starting all the way from the shop floor control programming, PLC programming, SCADA solutions, integrations, manufacturing execution systems, and so on. The recent 5 years, I've been more or less concentrating on building and helping our clients to build like hybrid cloud industrial IT solutions, whether it be manufacturing execution or data pipelines, data analytics, reporting and analysis solutions. So kind of like summarizing, I have, how to say, feet firmly on the shop floor and head high up in the cloud. A couple of words about Nortel. Nortel might be something that is not very familiar to many of our listeners. We are a global company. Today, approximately 1,000 people. We are a consultancy, technology, and software engineering company, headquartered in Estonia, Tallinn, Estonia. I come from our Finnish office, Helsinki, so greetings from the sunny Helsinki. And we've been in the business of industrial IT for more than 35 years. And we typically work as a tier one partner or like software partner, handling it from the shop floor to the top floor, from the consultancy, design, implementation, and maintenance and operations to many of our clients. We kind of like seamlessly work in all the levels of industrial IT landscape, coming from the, like mentioned, level 1 shop floor operations, level 2 SCADA solutions, level 3 manufacturing operations management, and all the way to the level 4 and 5 being the business operations and the nowadays like cloud and IoT solutions. So I would like to kind of like initiate our journey together with a simple, like a small question that, as we are covering a lot of the topics today related to how to building a hybrid cloud environment in industrial setting, I would like to pose a question that what is your or your company's level of adoption in cloud in the industrial IT landscape, and hope you actively respond to this. All right. I hope and trust everybody has had a chance to pick a choice here. So let's check the answers. Let's see. Here. All right. So that is very encouraging. So obviously, the majority of the companies and participants here have started their cloud journey at least on some level, and few respondents are having kind of like open to the idea, and even one is stating that extensively leveraging, and this is very promising. And none of you have responded that the cloud is not your thing. So this is something that I agree that it is something that is how to say, lurking into the industrial IT landscape as well. So to kind of like set up the stage and ground, I would like to kind of like raise up a couple of things that are typically encountered when we encounter our customers, clients, whether it's in energy sector. We work quite a lot with the metals and mining sector, forest industry, pulp industry, any kind of like discrete manufacturing or service industries, but more or less many times the kind of like challenges and trends are the same. Typically, here I've listed one of the most kind of common ones. Typically, clients are challenged with high cost of unplanned downtime, machines breaking up unexpectedly, and needing to do the emergency fix for the machines. This results in lost equipment efficiency, or the maintenance department needs to do expensive and frequent manual inspection cycles, and so on and so on. And obviously, when machines are run, and nowadays the energy is very obviously, especially coming from the metals and mining industry or forest industry, energy consumption and utilities consumption is very important topic there as well. Basically, I think the common denominator is that there are many things that are kind of like causing these challenges, are affecting these challenges. But I would like to point out and highlight one of the kind of like common denominator here is that many of these challenges come and kind of evolve from the fact that the critical information doesn't reach the decision makers in a timely fashion, so that the decision makers are not able to take kind of like action based on the data. And this is basically the challenge that we are kind of trying to today address. Some of the kind of like things that cause these are typically siloed and inaccessible data. So working in the shop floor, integrating machines and devices, many of the companies, even if they have, and they start with a very bold and like big picture and big, how to say, audacious goal to implement the data and analytics platform. In the beginning of the journey, you end up typically facing a lot of siloed and inaccessible data. So you have a lot of data, but it's basically locked inside automations of kind of like islands of automation, kind of like departments. So whether it's be a SCADA system, whether it's be some shop floor Excel sheet somewhere, PLC, maybe some manufacturing execution systems, database, whatnot. And breaking these data silos, integrating the data out from these data silos, it typically represents quite a large portion of the effort on these data journeys. The next step, once the data and integration challenges start to be kind of like tackled and you get your data to flowing in, one thing is very common that is very surprising, that how much there is data actually. And once you get the data flooding into your data lake, data warehouse, database servers, it is very surprisingly, suddenly you end up having like a millisecond resolution for millions of measurement points or tags flowing in constantly. So this data, especially this type of like device and process measurement data, it accumulates very quickly, and it's very easy to just like physically choke into this data, and not to mention about, even if you can store and process the data, how to draw insight out of this data. So this type of like data overload is a very, very often a typical challenge to the clients. The third, I think I would say like a trend or challenge what we are seeing in the market or in the client base is that I call it inflexible monoliths. We all know that the previous decades have been the promised time of huge ERP projects, monolith ERP projects, and even like MES projects, manufacturing execution system projects. typically these systems have been implemented and deployed as like a typically on-prem applications, single bloated monolithic application running in the company's data centers and so on and so on. I think this is the times are changing. Even the ERP vendors and more industrial vendors are also taking the approach of having these more like efficient, modular, typically API-driven ecosystem thinking, where these monoliths are basically broken into smaller services or even microservices and integrated with highly kind of like integratable API interfaces. So kind of like breaking up the monoliths into API ecosystems. This is one of the kind of like challenges that trends we are seeing in the market. We at Nortel, typically, obviously, we do all sorts of things, but for today, I would like to highlight a couple of kind of productized packages or like the services that we offer to our clients and heavily work with, especially in the beginning of the cloud or data journey in the industrial landscape. It all starts from integrations, IT/OT integrations, how to kind of like break those data silos, how to bring data in a consolidated and standardized and templated way into the data platform, and then how to manage and serve the data for the business applications onwards. What I'm going to give you today is hopefully a set of tools, principles, best practices, tips, and some guidelines how we are doing it. We are heavily relying on kind of good products like engineering tools. A couple of to mention what we are going to see is PTC, Kepware, Skep Server EX as a connectivity platform, InfluxData as a time series database, and then today we are covering the solution demo built on top of Microsoft Azure, but the similar approach can be taken and has been taken in also other clouds than Azure. Good. So it's time for the next question of my presentation. So I would like to know that where are most of your industrial data stored today? Great. I believe, I hope there's enough answers, so let's check it. So, great. Once again, I'm very excited to having this result. So half of you say have responded that most of the cloud is already, data is already in cloud data warehouse or data lake. But still like 25% in SCADA systems, 25% in department or site level MES systems. So actually this is a really good trend. Kind of like we can see that none of the respondents have stated that this data warehouse or data lake has been developed or implemented in on-prem server or data centers. So this is really, really cool. All right, I think we will next start uncovering the kind of like one of the main topics of today's pitch. So time series data. Coming from the industrial world, for me, the time series data has always been kind of, I have associated it with industrial devices, machinery, whether it's pumps, whether it's some, I don't know, engines, conveyor belts, robots, whatnot, basically. So for me, time series data has been always like industrial IT or Industry 4.0 related data. But when we are looking at like a broader scope, we can see that time series data is actually the fastest growing data storage or data category in the world. We can see it everywhere, fleets and assets, vehicles, self-driving cars, building automation, IoT, intelligent lamp posts, whatnot. Healthcare and wellness is very like a growing business, and more also kind of like we see that when DevOps practices, automated application monitoring, and these kind of like practices have been moving forward. Time series data is also a really relevant type of a data in these applications and DevOps monitoring kind of like domains. So this is also kind of like visible in some of the like statistics and trends. This picture describes the trends from the last 24 months and about which kind of like data storage types are the most popular based on what is around in the internet, based on the search results, how much people are interested, how much people are looking information, how much people are interacting in the community, and so on and so on. So we can see a huge kind of like growth in time series database area, which is quite I think well resonates the previous message. Also, if we look more concretely, how does this time series database storages look like? In general, overall, 90% of the world's IT organizations in worldwide are running on top of or using some sort of like open source software for mission critical systems. And coming from the industrial IT background, sometimes it has been a kind of like very, how to say, like a difficult to start a discussion with a client that, okay, why not use an open source based technology in this and this? But nowadays, almost everything runs on open source. This is especially, how to say, visible in the time series database domain. So based on the statistics, more than 80% of the time series database technologies are of open source technology background. And this is also kind of like evident in the statistics. Also looking at what kind of like tools and technologies are typically used for storing time series data. Obviously, this is not industry specific, but in general, overall, how community is using time series database storage solutions for storing this data. So we can see a lot of tools coming from the open source background, and noting also that InfluxDB has consequently ranked as the most popular database storage solution in this domain. Okay, so then sometimes people ask me that, okay, we have time series data, then we have historian or industrial process historian. What's the difference? I don't know if there is any official kind of like description of this, but for me, a historian is a kind of like time series database solution designed specifically for capturing data and storing industrial data. So if we kind of like simply slice and dice it, what are the kind of typical layers or components? On the left-hand side, we have the data collection and ingestion capabilities, ingesting data from all the different industrial devices like devices and protocols, PLCs, SCADA, OPC systems, Modbus, whatnot. Doing some pre-processing, filtering, buffering, and forwarding. It's very important for buffer and forward when we have like intermittent connectivity or how to say, like remote locations and so. Obviously, storage, high throughput, high scalability, high availability is kind of like relevant parts. And then delivering this data and enriching like different visualization capabilities, events, automated tasks, and APIs, how to consume the data. So very, very kind of like typical stuff that you might expect having in the database. What I put here together is that I have to say it's quite sunny weather here. I'm kind of having difficulty seeing my slides even. So, okay, but what I put here together is a simple kind of like, this is my personal handpick kind of a comparison of some of the characteristics that I typically see when working with, how to say, traditional time series or industrial historian tools coming from the traditional world compared to what we have recently been used to working with, how to say, like next gen or like modern time series historian tools. Is that first and foremost, I think that many of our clients are really highly valuing that we have good connectivity for our industrial data sources. So OPC servers, CSV files, ODBC databases, some VB, .NET, Excel, whatnot. And this has been kind of like one of the kind of like big, how to say, challenges for adapting new type of technologies, because there hasn't been previously available, you know, OPC interface or PLC interfaces. But this is also nowadays very well covered in the modern age time series databases. So typical next gen or modern age is providing first and foremost APIs, good high quality APIs, and then hundreds of plugins implemented by the community or the vendor, including also OPC UA. Obviously, how the data is served, OPC on and CSV and ODBC on the traditional side, and more like API and plugin-driven architecture on the next-gen side. Then comes to these differences, how you typically deploy your historian in traditional world is either VM or even like on hard like server. But on the modern side, the deployment is typically obviously VM-based, but more and more containerized or managed cloud deployments. Scalability is very important, having ability to scale out instead of scale up, having ability to add more nodes to cover the compute requirements of the database and so on. Obviously, traditional world of point and click. I know I've been working with, I don't know, half a dozen of commercial historian solutions, and every time kind of like the challenge has been the point and click way of configuring the solution. And nowadays everybody's looking into the DevOps and automation, how to do script your solution, how to run your DevOps pipelines, CI/CD pipelines to deploy kind of like immutable infrastructure and so on. And this is very kind of highly valued on the kind of like new age developer community. And in general, community and business models are a little bit different from the closed community, more to the open community, and from the like purely commercial business model to having options of running open source, free version, having enterprise support, or having your historian solution in managed cloud as a subscription based. All right. So moving forward, next I will shortly introduce you the demo setup that I have prepared and planned to run. So in this demo setup, we have on the left-hand side devices. I'm going to shortly demo how to connect some of the devices using Kepware KepServer, how to push the data into Azure IoT Edge, then how to connect Azure IoT Edge in the Azure IoT Hub, run the streaming pipeline using Azure Functions, land the data in InfluxDB Cloud, and then on top of that, I hopefully have time to, or I will reserve some time to actually demonstrate some of the, I would say, data consumption scenarios, how the data can be then consumed by the different applications or different roles in your factory or organization. Okay, so then let's pray for the demo gods and start the engine. So I will share my screen next. Yeah, let's see here. Okay. I have my demo environment open. I have my screen shared, and I'm running a VM. This is just a demo environment. And first and foremost, let's start with typically where it starts, from the very control engineering point of view, how to connect your devices in the basically on the edge or on-prem systems. So what we are seeing here is that we have a really good tool, really a best friend of a control engineer, PTC Kepware KepServer EX. I've been using this for more than a decade in almost every project. So basically what we have here, and we have ability to create new channel, we have ability to select the different, we can pick and choose what is the device type we want to connect. Coming from the Europe, I would say 90% is Siemens, but it can also have anything, Allen Bradley, Honeywell, Rockwell, whatnot, basically. Then we connect to the device, and then we just create our OPC tag configuration using some of the kind of like configuration parameters. But because today's topic is not kind of like deep diving into how to connect to the PLCs. So I will trust you to kind of believe me on this. And if you want to have a closer discussion how to integrate to PLCs, just drop me a mail. But what we are now kind of like jumping in is that I have created a simulator channel where I have one simulator PLC called Device 1. I have pre-created a bunch of simulation tags. These are just sensor simulator tags that are following sine curve with some differentiating like parameters. And we can just quickly drop into our OPC client and just verify that we have, yes, we indeed have live data. The data is updating, data looks good, and so on and so on. All right. So now we have the connectivity to the PLC, and this is very traditional control engineering, automation, connectivity type of an effort. The next step is that we have an IoT edge. Azure IoT Edge is typically preferred running on Linux box. So now I'm connected to my IoT Edge module, and basically there's not much here to see, but just to kind of like give a proof that I have IoT Edge, I can do logs, I can take, let's say, tail last 50. So yeah, I've probably, forgotten IoT Edge. Yeah. Okay, we can take a look at the IoT Edge capabilities directly from Azure portal. I think it's more meaningful. Yeah, I'm not really good at remembering by heart all the syntaxes, but let's just pop up our Azure portal. So now we are looking my Azure portal. Here we have my demo IoT hub. We can see that this is streaming data. We can see the data is coming in every day. I have actually a limit of 1.6 million 1.6 million messages per day, but we can see the data is flowing in. And if we want to actually look the kind of like what's the data, is that I can just quickly look what the data looks like in IoT Hub. So I will just go ahead and look my snippets for how we can monitor this data. One thing in Azure, it's not, sometimes the portal doesn't provide you with very good kind of like built-in like a graphical user interface for monitoring some stuff. But then again, Azure is very good at having these, how to say, like command line tools. And now we can see, now I'm monitoring our Azure IoT Hub, and I can see my OPC server where I have PLC simulator. It's streaming the data to Azure. We can see the tag name, timestamp, value, etc., etc. So we have now the data flowing in. So the next step, now we have the data here in Azure IoT Hub. The next step is how, one way or another, ingest the data to the database. And I'm using it for the data ingestion. I'm using a simple Azure function, which is actually a serverless solution, really cool feature in Azure. It's a simple function, and its sole purpose is to kind of like grab the data from the IoT Hub and then push the data into InfluxDB. There's a lot of different options to how to implement this streaming pipeline, but I have chosen the functions because it has also kind of like a very, how to say, flexible approach if I want to do some sort of like streaming analytics or data cleansing or something like that. So we can see typically we have events flowing in. IoT Hub triggers this function. It processes 491 events, and so on and so on, and it pushes it into the InfluxDB database. Good. So the next thing is that now, if we look, we have covered PLC integration, IoT Edge, IoT Hub. We have shortly covered the function. So now, if everything goes well, we should have the data landed here in InfluxDB Cloud. And what the InfluxDB Cloud is that there's multiple options from InfluxDB. We can use either, in our case, I use the InfluxDB like managed cloud in Azure. So it's a cloud managed database as a service provided by InfluxData, and it's very quick to value and so on and so on. So I have created my account. I have configured some of the stuff here, and I can see my OPC data is now flowing in. I can see, if I look from these, I can say the tag name. I have a bunch of tags. I could say that last 5 minutes. And basically, this is the data, how it looks like in a really raw format. And I could go and select only a couple of tags and say submit. So this is the raw data now in real time published. I can update. We can see the timestamp is, we are on the right time, basically more or less real time. So everything looks good. But what I typically use is that even though the InfluxDB has quite nice user interface, I typically end up having some visualization tool like Grafana, for example, for control engineers for visualization, Power BI for business people or reporting and analytics, and Databricks for data engineers, and obviously for software developers, and like a rich API interface, how they can interact. And just to give a quick view, this Grafana is a really great tool, like a companion to InfluxDB. In this Grafana, for example, this is exactly the same data. There are a couple of benefits using Grafana, for example, having this automatically updated dashboard view, more visualization options, more options to kind of like do alerting. You can send your alerts to Teams or Slack or some other channels, make a kind of like alerting rules, or push as an email, obviously, and so on and so on. Make annotations to the data, basically create an annotation and say that, okay, I have seen something here, and it will store the annotation, and so on and so on. And also this is also Azure AD integrated, so I can use my Azure AD account to log into Grafana. All right, so then what is typically asked is that like the Grafana is really good way to kind of like have a visual on the raw data, streaming data, the time series data, process measurement, I don't know, temperatures, vibrations, energy consumption, piece counter or whatnot. But typically business users want to use OPC. And what we have done and typically do is that then we tap into the InfluxDB like database using API in Power BI. And then we typically enrich the data by having the asset hierarchy model or plant model or digital twin, whatever you want to call it. So basically, the InfluxDB typically contains the how to say, raw tag data. Then we have a hierarchical model of your equipment that has a kind of like linking between the hierarchical model to the tag. And then we are able to kind of like pull together reports, dashboard reports in Power BI, where you have ability to bind kind of like build context around your raw data. And obviously, there's no limitation what kind of data you can pull in your BI tool, whether it's your like maintenance management data or ERP data, customer orders, whatnot. So basically, you can build very rich business reporting and like visualization solution in Power BI or in any other BI tool using the time series database, InfluxDB in this case, in the background. Just by the way, being very conscious of the time, I think our time is more or less up today. What we covered, a really quick summary, is that I will stop sharing. Yeah, so what we have time to cover is the connectivity to PLC, pushing the data through OPC server to IoT Edge, IoT Hub, streaming pipeline, InfluxDB Cloud, which was a managed cloud service, visualizing in Grafana, typically for control engineers, ad hoc analysis, putting it some BI reporting in Power BI. What we didn't have time to cover is the Postman, but basically it's more or less just a demonstration how it's nice to use rich and quality APIs for building any type of applications. And for further kind of like teaser, please, if you are interested in discussing how this data could be leveraged in the data engineering workbench, don't hesitate to contact me. I think that was basically the topic that I was planning to cover today. And yeah, I don't know how much we have time for questions anymore, but sorry for taking more time than expected.
Thank you so much, Ergin. That was a great presentation, very informative, and great that you could screen share and show us. For those in the audience, if you'd like to listen to Ergin's presentation again, it will be available on demand. And finally, thank you to you wherever you are for taking the time to listen in. We look forward to having you on the next session starting in just a few moments. And again, thank you so much, Ergin, for your great presentation.
Thanks.